All right, good evening, everybody. My name is Elena. I'm one of the TAs in Data Analytics program. So today, the purpose of today's meeting is to introduce you to R and R Studio, and this meeting will be recorded. All right, so let's go ahead and get started. Here is tonight's agenda, and what we're gonna cover the RStudio interface. We're gonna cover how to create an R script. We're gonna cover the variables. We're gonna cover reading data from the CSV file into the variable called data frame, and we'll cover the data frame properties, how to apply filters, row filters and variable filters. We're gonna do some data visualization, and guess what, guys? There is a bonus for attending this meeting or for watching this recording. And the bonus is three-dimensional plots, right? So that's going to be the bonus. All right. So here what I did was I put two links for you. This is very important. You need to install two programs. The first program is R, right? And I have two links here for Windows and for Mac. And another one is RStudio. That's an interface that we're going to use to type the command and to see the output. So I'm going to go ahead and share my screen, and we're going to look at the RStudio interface rather. Share my screen. There we go. So what I did here is an RStudio, right? This is how it looks like, and this is what it's gonna look when you first open it after installation. So I have on my left panel here, this is where I'm gonna enter my commands, and this is where I'm gonna see my output, right? I have another panel here, environment. Environment, it shows me everything that I have loaded in memory. It could be the data, or it could be just a variable. Yeah. Right now, I don't have anything because I have not started my work, right? So here, history, this is a history of commands. When you start, you're not going to see anything because it's going to be empty. But since I've been practicing, I've been doing some commands in preparation for the WebEx, right? I have something in here already. Now, here I have 5 tabs. Files, it's gonna show me the data files in my current directory, and I'm gonna go over what the working directory is. Here I'm gonna see my plots, right? And we're gonna cover how to do that, and we're gonna cover what packages are. And here is the help. So basically, I can search on information on a package or in a function. I'll show you how to do that, right? So this is the tab where you'll see. Now, I'm going to introduce another window, and this is very important. When you do this work, you want to make sure that your work is reproducible. So to do that, we're going to save all commands in a script. Look, file, new file, R script, right? So what it's going to be is, it's going to be a file which I'm going to store all the commands that I'm going to write. Like, for example, just an example, if I want to write 2 plus 2, all right, it's a command. And if I want to save it as a script, so what I'll do is I'll just go File, Save As, right? I'm going to go File, Save As, and I'm going to save it as an R file, right? That's in general how I do it. But what we're going to do now, I'm going to go ahead and I'm going to open the script that I wrote for today's demo. So I'm going to close this out. I don't want to save this. I'm going to do this file, open file, right? And now I need to remember where I saved it. I saved it on my desktop, and I call it Introduction to RStudio. So here is the script that I wrote, and I want my code that I write to be reproducible, right? So basically, what I did here, first command that I'm going to show you is how to find out what version of R I'm using. Well, first of all, when you load an R version, you see the steps in the console. It shows you, right? But what if it did not? R.version command is going to show you what R version is installed, right? Here we go. Now, as you may or may not have noticed, we can use an RStudio as a calculator. So I can just type in 5 plus 9 and I can run it. How do I run it? I just put my cursor on a command and I hit run here. That's one way to do it, right? Now, what I want you to notice that in R, everything is a vector. So what I did, 5 plus 9, behind the scene, I created a vector, right? It's a vector with a single element. It's not going to be stored in a variable because I have not stored it anywhere, right? It's still empty. What I did was just, I printed the result to the screen. There is only one element, right? And I don't see, I have not stored anything, right? I have not stored anything in my variables. Now, what I can also do is I can print the text to the screen. For example, welcome to data mining. It's just going to print the text. Again, notice this. I have one element, and here it shows the index of an element. Indexes of the element starts from 1, right? Unlike in other programming languages, they start from 1. Now here, ls command is going to show me all variables I have in memory. Now it's going to be empty. It's actually, in other words, it's going to list everything you have in the environmental tab. Right now I have nothing, right? And this is another way to display all objects in memory, is to do objects command. Now, here, I just did the calculation. I didn't assign anything. What I'm going to do over here is that I'm going to create a variable called x, and I'm going to assign the value of 3. Now, notice that assignment. So you have less than, right, and minus. That's an assignment operator. This is an assignment operator in R. And notice that the direction where this error points to, right, it shows me that I'm going to assign in the variable to x because of direction. So I'm going to run this now. And what I did was it created a variable in here, and value is x. So now, if I run this command, let me run objects right now. It's going to show me that I have one object in the memory, x. Now, what I want to do is, suppose that I no longer need it. Notice that here, broom right here. If I click on this broom, it's going to delete every single object in here that I have, right? But you want to be careful. What if I have 10 variables in here? I want to delete only x. This is how I do it. I run command called rm, and I pass the variable names that I want to remove. Gone, right? And here, this command is gonna let you remove everything in the memory. Now notice that here, ls, right, it lists, ls command, it lists all variables that I have in memory, right? And here, to my rm command, I'm passing the whole list, right? So this is a nested command, in other words. Right now, I don't have anything, but if I do this, I just do this x, and I'm gonna set it equals 2, and I'm gonna set y equals 3, right? So see this, I have two variables. When I run this, it's gonna remove both of them from memory, and we're gonna have a copy of this script afterwards. So now, this is very important, vectors. Vector is basically a list. So here, I'm gonna create a list with 5 elements, 1, 2, 3, 4, 5. Now, what is it going to do? It's just going to print it to the screen because I have not assigned it to a variable, right? Now, suppose that I want to assign it. So this is an assignment operator, and here it's going to create a variable called x. Now, here, keep in mind, R is case sensitive. So what I'll do is here, I'm going to create a variable x. And what this means is that it means take elements, take numbers from 1 to 5. Column means take everything between 1 and 5, right? So here is my variable, and here are the values. Now, in order to print the variable to the screen, right, you can use the print command, or you can simply just put the variable name and I run this. And what it does is it's going to output what I have in variable x. What is this? This is an index of the first element on a line, right? So which is 1. I mean, this is an index, right? So the first element starts from 1. It's going to make more sense later on when we have an output that wraps into multiple lines. So now what I can do is I can do the class, take class of variable x. Well, it's an integer. It means that on my list all elements of integer type. And this is another way I can do type of, right? It's going to show me the integer. And str is going to show me the structure. Str command shows the structure. In this case, it's going to show me that it's an integer variable. And here, it's just going to show me that it has 5 elements, and here are other elements. Here, what I'm doing here, this is a little different. I'll show you what I'm doing. I want to have the values 1 through 5, and then 8 through 10. One way to do this is I could list it 1, 2, 3, 4, 5, 8, 9, 10, right? But here is a shortcut. I want 1 through 5, 8 through 10, right? There we go. And here I'm getting the class of y, str, and now something else I want to show you. I can multiply, right? What this will do is this will multiply every single element in y by 2, right? Y times 2. And here it is. Right now I see it in the output. Now this is a little bit tricky here. I multiplied it by 2. I see the result here, but I don't see it here, right? The y in here did not change, and the reason is because I didn't assign it, right? In order to see changes here, I would have to assign, and let me show you how to do it. So now, here it is, and I'm gonna put y. I'm gonna put y, uppercase y, and here is an assignment operator, right? And then I hit enter key. There we go. Now it did. One thing I want to show you here is that you can go back and forth between the commands and the history just by hitting the up and down arrow keys on the keyboard. Watch this. So that way you don't need to retype, right? It saves you a lot of time on typing. What you could also do is you could go to history, and to run the last command that I ran, I'm going to highlight this command, and I'm going to do the to console, and then I run it, right? So here, what I want you to notice that this stuff in green, see this hash mark, and everything in green, this is a comment. The comment is not an executable code, but it tells me what my code does, right? So it's really helpful because after that, you're going to have a copy of this script with the comments. Now, here it is. What I'm doing here right now is the sequence. This is very important because you might be using sequences or lists as an input to another function that you run. So here what it's going to do is it's going to produce a sequence of elements starting from 1 to 10, right? Because I didn't say where to start from. And if I don't say where to start from, it's going to start from 1. And if I don't say the increment by, it's going to be 1 by default. So I run it, and here it is, right? Now I'm going to do another one, W, and here I'm starting from the 2, right? Oops. From 2 through 10 it should be. Oh, okay, I see what it is. So now let me do another one. Okay. Okay, I'll look at it later. But anyhow, this is how you would do the sequence, right? Now, what we're gonna do is let's clear it up. Okay, let's clear it up here from the memory. What I'll do is I'm gonna need to do this rm command, right? There we go. So I just cleared my memory. Now what we're gonna do is we're gonna read data from the file. In your first assignment, you were using the iris data. Iris data comes in with RStudio installation, right? It's already there. But what I want to do now is, instead of using the built-in dataset, I want to use my own dataset. And this is how the data looks like. Cleveland data. and it's gonna, I have the patient's information, age, sex, and the vitals, and here it's gonna tell me if an individual may or may not have a heart attack, right? So this is equivalent heart data from the heart study. Let me minimize it, and I want to read the data into R. What I need to do is the first step, I need to set my working directory. And what's a working directory? It's a folder on my hard drive where R is going to look at first when I try to read my data. All right, when I try to read the data, there is more than one way to do it. Here is how you do it programmatically. Set WD, that's a command, and in here, in the quotes, I'm going to put a path. Here, your path is going to be different because that's where you're going to save the CSV file on your hard drive. For me, I have an external hard drive A, and I have a folder that I call dataset, right? So that's a command. But you can also do it this way. You can do the session, see the session, set working directory, right? And here you choose the directory, and here what you need to do is you just find the folder where your file is, and it's right here, all right? And you just select folder. There it is. And behind the scene, I run this command on my behalf, right? But here's something that I want you to keep in mind, that you want the code to be reusable. If you use the menu to set the working directory, R generated the command for you. What you need to do is make sure that you copy this command to your script, because when I have to rerun the script, I just want to rerun the command. I don't want to be playing around with menus, right? It's much easier to rerun the command, all right? And something important to keep in mind, that there is no undo command. I mean, I can undo the changes to the code in my file, but I cannot undo the variable deletion, right? There is no direct way. I deleted a variable, and I figured out I needed it back. One way to restore it is to run the code. That's one reason why we need to have the code reproducible, right? That way you can restore the work that you did. So here, I'm going to run this command, right? I already did it. It's at working directory. And notice that right here, it says what my current directory is. Alternatively, I can run this command, get WD, and it's going to show me what my current directory is. This command lets me list all my files in the working directory. So perhaps I don't remember the exact spelling on my file name, and I can just look it up. Now here is a perfect example. See this? The files list is printed as a vector. Here is an index, right? The number here is an index of a vector element that starts a line. So see this number 3, because this is a third file in my directory. This is a fifth file in my directory, right? So that's probably a good example. Now what I'm going to do is I'm going to read my data into the data frame, and I call it equivalent. This is a variable. Read CSV command is going to read data from the CSV file. Equivalent is the file name, equivalent.csv. Now, what I'm doing here, I'm saying header equals true. Notice that my first row in this file is a header. I want this header here to be my variable names. That's what I essentially want, right? So let's minimize it. And I say header equals true. Separator is comma. Well, it means that the file is comma delimited, right? Usually it is a default, but we don't want to rely on default. We want to explicitly state it. There we go. So now notice what it did. Over here in my environment, I have a new variable. It's called equivalent, and it has 303 observations, right? Each observation is a data row in my file, in my CSV file, and I have 14 variables, right? Each variable is essentially a column, and you in the spreadsheet, and you're gonna see it called variable. You're gonna see it attribute. You're gonna see it field. Those words are used interchangeably. Now what I'm gonna do is, there's more than one way to preview the actual data. To do this, I can do the view command. View is gonna display my data in a spreadsheet view. Yes, it's gonna open another tab. And what is this? This as a variable names, right? And here, it's gonna name the data row for me. So in this case, it's just numbers. And here are my values, right? I can just play around, I can filter, I can sort it. And here just showing me that it's showing the first 9 rows. Yeah. Now, let me close this out. Now here, there is a head command, and this is gonna be your friend, trust me. Sometimes you want to preview what the data looks like. So head command is gonna show me the first 6 rows. Now, we need to keep in mind that this command takes some input parameters, right? But by default, 6 is only the default. What I can do here, I can specify. So here, I'm gonna do 10, right? So some commands in R have required input parameters, and some input parameters are optional. If you don't specify, there is a default. So default is 6, right? So here I specified I want to see 10. It's going to show me the first 10. Tail is, on the other hand, is going to show me the last command, last 6 data rows rather, right? It's going to show me last 6. But if I wanted to display last 10, this is what I'm going to do. I would have to put comma 10, right? That's it. Yeah. So now fix, what this is going to do is, we're not necessarily going to use it, but I wanted to show you. It's going to open the data in preview mode, in editing mode, right? Let me close this out. This is not a good practice. So any editing that you want to do to your data, I would recommend you do it before you upload data into R, right? So now what we're going to do here is we're going to show the structure of the data. So basically, one way to preview the structure is to look at this environmental tab right here. And here it's showing me my variables, and it's showing me the data types for each variable, and it's going to show me the first few values. Notice that at the moment all my variables are numeric, but we're going to fix it, and I'll show you why. So here at the moment it's showing me the preview of the first few values, number of observations, and number of variables. And I can obtain the same information by running the str command right here, right? So this is a structure. Now there are additional commands in here, names. What if I want to see just the variable names? I'm going to run the names command. That's one way, right? Now there is another command called attributes. And this command, it returns several elements. It's going to return me the variable names, right? It's going to return me the row names. Well, basically, row name is a row number in this case. It's going to return me also the variable data type, which is a data frame in this case. Now, notice that this output here is a list. It's a list. And a list contains 3 elements. This element, the first element, is called names, right? And names stores the names of my variables right here. The second element of this list stores the row numbers. Well, it's actually row number is a row name in this case, right? And here it means it's a data frame. But one way to display only variable names is this attribute, and in the bracket I'm going to specify 1. It means I want to see only the first element, which is variable names, right? Another way is to do column names. And now, I forgot to mention, in parentheses here, what is this? This is a data frame name, right? Here is my data frame. And this is case sensitive. If I did this, for instance, it's not going to know what my equivalent is. I'm going to get an error, equivalent not found. So whenever you get this error, you want to check the spelling. You want to make sure that the spelling is consistent, right? right? So now what we're gonna do is, if we want to see the number of variables and the number of data rows, right, at a dimension, one way to do it is to run the im command, and it's gonna show me the same information that I see here, right? And row command is gonna show me the number of rows, number of data rows. Now here, one thing about dimensions here is it's a list of 2 elements. So if I want to see only the number of rows, I can run dim command and I can specify index 1. So that means I only want to see 303 rows, right? Similarly, to display the number of variables, I can do ncall, right? It's going to show me number of variables. I can do length. Here, what I could do is I can also do the dim command and take the second element. Do you remember it? The dim command, it returns 2 elements. Here, number of observation, and here is my number of variables. So if I take the second element, I'm getting the number of variables. And also here, what I'm doing is, do you remember length, right? I'm sorry, do you remember the names? Names, right? It's a list of variable names. The number of variables is the length of this list, basically. That's what I'm doing. Here, names command is going to return this list, and I'm taking the length of this. So that's another way. Oops, I went too fast. I ran the next command. Anyway, here is an output, right? 14. Now here, this command is going to show me the descriptive statistics for a data frame. So what it does is, here's the data frame name, and it takes it as an input, right? This is what I just ran. And what it does is, it lists every single variable, and it shows the statistics, like the minimum value, the maximum value in the first quartile range, mean and median, because currently at the moment all my variables are numeric, but we're going to change it shortly. Now, here it is. See this NA. What NA is, it means that the value is missing, unspecified. And we're going to discuss the missing values in a few. Now, this data set is only 14 variables. Suppose that my data set had 200 variables, and I want to know the statistics only for an age variable. Am I going to scroll through all 200 variables to find an age variable? I don't think so. So what I can do here, I can run the summary command only on one variable. So to do that, the input parameter is going to be the data frame name. So I put a $, and I put the name of my variable, right? And here, I'm going to run this command, and I'm just going to show me the statistics for an age variable, right? And notice that I don't have the one in the brackets because this is not a list. This is just showing me the statistics for this variable. Another way I can do to show the statistics for all variables, there is a command called lapply. What it does is, it goes through the list of my variables and it applies the specified function for all variables. So lapply, equivalent is the dataset name, a summary in the functions that I want to run. There we go. Basically, it returns the same, almost the same information that the command right here, except it's a different format, right? Nice thing about R is that there is more than one way to produce the same output, and I'm giving you several options here. So now here, what if I want only minimum, right? I can run the minimum. Now what if I want just range, right? Range is a minimum and maximum value, right? Now here, one thing you may notice is missing is a standard deviation. It's not part of the summary command output. So I can run the SD command as a standard deviation, and I want it only for an age variable, right? Now I can also do the unique. So unique, what it's going to do is display the unique variable values. Right now it's 1 and 0, but we're going to fix it because I'm going to show you the dataset description, and it describes what 1 is and what 0 is, right? Here, this is an aggregate. So what I'm gonna do here is that I want to see the average value of the cholesterol, but I want it by the sex, right? Uh, I want an average value, but instead of taking the average, the mean value, the way I did it over here, right? Back up. Here, it was giving me an overall average for the whole data. Here, what I want is, I want it broken down by the person's gender. Run. Oops. Here it is, right? So here is a gender. I have a gender, and I have an average value of the cholesterol. How do I do it? I use the aggregate. Here, I put a variable that I want to apply the function to. Here, I put the sign tilde, and here is my grouping variable, right? I want to do it by the sex, right? And here, the function is mean. Similarly, I can do the maximum here, right? Now, what if I want to do it for more than one variable? I want to display the cholesterol, average cholesterol reading, and average age by sex. So what I'm doing here is a function cbind, right? Cbind. Because here, what I'm doing is I'm producing just one column, right? Cbind is going to display this, the single table, basically. I want to display the output, the average value of cholesterol and a gender, of cholesterol and age by gender in a single table like this. So I use a cbind, and in here, in parentheses, I specified the variables, right, that I want to see. And notice that it named it for me. It named it for me, variable 1, variable 2, right? And here, it's showing it. This is a variable that I want to use, right, for the grouping. And here's a function in the mean, right? So what you could also do is you can run a help command on the aggregate. So to do this, you put a question mark and a help command, and you notice that you can also rename these variables in here, the v1 and v2. What you could do is you can play around with the options to rename them, right? You can play around with this, and I'll leave it to you to play around at your leisure. So now what we're going to do is we're going to display the subsets. How do I take the first 5 rows and all variables? One way to do that is to run the head command, right? We can run the head command and we can specify 5, right? We can do this, do you remember? And see this, as I type, it's going to show me, it's going to attempt to show me what I want, right? So this is one way to do it. Another way is to use the indexes. So in the brackets, the first number here is a rows range. I want rows 1 through 5. Here I specify the columns. But if the column specification is omitted, it means I want them all. So this is going to return 5 rows from this data set. So when you're asked to display the first 5 rows, you can use the head command or you can use this command. It does not matter. In this case, it's going to produce the same result, right? However, here it's just an output. I did not do anything, right? Notice I don't have a new variable here because I did not assign. Now I can assign. Remember the assignment, and the error points to the variable that this is assigned to. Right? I'm going to run this, and here I have a new variable, and I have only 5 observations and 14 variables, the subset. Now what I'm going to do is, I'm going to specify 6, right? I want to take the first 6 variables and the first 6 rows, and I want to output, right? Now what I'm going to do is, that's another way to do it. Do you remember names? It returns a variable names. Name returns a list of variable names. and I'm taking the first six variables from the list of variable names, just another way. The same result, right? Here, I want to only see the first 5 rows and the column 1, 4, and 5. Now, see, do you remember over there? We did it for a reason, right? We created the list for a reason, because the lists are used inside of other functions, like what I'm doing here. In order to list the columns, the variables 1, 4, and 5, you have to use a C function. This is a list, right? So what let me do is I'm going to run this, right? Now here, what I want to do is I want to explicitly specify which variables I want. So I have to put like this C, which means for a list, and here I have to list my variable names. So I need the first 5 rows and variables H and CP. I'm going to run this thing here. Yep. So now what I want to do is here I want all rows. See this? If I want all rows, this is omitted. Run. There we go. Right? All rows and just 2 variables. Here I want only a specific variable and the first 4 elements, right? The first 4 rows. So here I put a $sign and I specify my variable name H, and I want elements 1 through 4. Now, this is a single dimension, right? Because I only take 1 variable, so that's why I put 1 through 4. While here, it's a 2 dimensions, right? Because this is a data frame here. Right, so now what I want to do is, here is a conditional. I want to select every single row. I want to select every single row in my data set that has the age above 60. Now, remember what this does. What this by itself does is, it's going to output for each row, it's going to output if the age is greater than 60, right? This is what it does. Here, I want to take a subset where age is greater than 60, so it's going to pick up all the rows with an index where this here is true. It's going to pick up a row with an index where this expression right here returns a true value. Here, we specify the columns that we want, but the columns are omitted, right? I want everything, and here is a condition. Age greater than 60, right? 1. See, this is what it did, but if you do the comparison, the row numbers that got returned and which values here are true, right? So row 1, I should see row 2, I should not see 15, right? I should see 85, and so on. So then you can go in the data set and actually compare, right? Now here I can combine my conditions. So what I'm saying here, let me see the data rows where age is above 60 and the cholesterol reading is above 400. So let me show you what this does first. This, for each data row, it's going to return if the row meets the condition, right? True and false. It's going to show me if the in the data row, if the age is greater than 60 and the cholesterol reading is greater than 400, it's going to be true. And here I'm picking up all rows to which this condition applies, right? So this is important, and you'll see it later on. Now here, how do we want to add a variable to the data frame? Add a variable. If you look at it here, equivalent, right? I want to add a variable, and let's call it new age, right? It's not in here right now. To do this, you just put a data frame name, $sign, and you put a new variable name. Here is an assignment operator, and I'm gonna take the age values, current age values, and subtract 1. So let's say I have a new variable and I'm going to make everybody 1 year younger. I just do this, and here it is. I'm going to see my variable in here. If I scroll down, one way to verify that the variable was added is to run str command, right? We can go up there and we can run the str command, or we can also run the names command. It's going to show me, it's going to list my variable. So that's one way to verify that the variable was added. You just run the names command. It's here. Now what we're going to do is, I'm going to show you how to remove the variable. And one way to do it is just to assign null value. Null, it's uppercase, N-U-L-L, right? So you put the data frame name, $, variable name, and set it to null. There we go, and it's gone. To verify that it's gone, you have to run the names command. That's one way. And see that it's no longer returned. Now, here, remember it index, right? It's an index of the first element in the list. So here, that means it's my nines variable. Elements start from 1. Now, sorting. Here is a tricky part. I want to see the 10 eldest people. I want to know who my 10 eldest people are. To do that, what I need to do is I can create a copy of the equivalent data, sort it. But to do that over here, I have to specify that I want my rows to be ordered by variable age. And by default, the order is ascending, I believe, yes. So I want to see, for instance, 10 youngest people or 10 oldest people. To do this, you have to use the order command. But the problem is, if you run the order command by itself, it will only order the age, right? I want my data frame to be sorted. I cannot just use sort, rather. I cannot use sort command myself, just by itself, because I want the whole data frame to be sorted by the age, right? I want people to be sorted based on age. And here I'm creating a new variable. I'm taking all columns and I'm going to order all my data rows by age. Let me see what happens. All right, and I'm going to run it, the head command to preview. And see this, the default sort order is accented. So it's going to give me the first 10 youngest people. So this is one reason you want to sort data, because I want to see 10 youngest people, I want to see 10 oldest people. Now, to sort the data in descending order, you have to put minus sign. Here it is. Let me show you. Right? And then I'm running the head command to verify that my data is sorted. Right? Here we go. And here is the eldest person is 77 and so on. Now, I can sort by 2 variables. So what it means that if I have a tie, how do I treat people if I have 2 people with the same age? Like see that here, I have 2 people who are 34 years old. If I wanted to see only 2 people, right? What criteria would I use to select the second person? See this? I can add another variable here. So I'm sorting it by age, and here I'm sorting it by cholesterol reading within the age. Right? And I'm going to display the first 10 rows. So basically, here I'm sorting by this variable within the age. And you can even do more. So I'll let you guys play around with this. Now, I'm gonna, so far, the variables we looked at were numeric. Numeric variables values are basically numbers, right? Now we're gonna look at the factor variables. So if you notice that this data set, it comes from this library, machine learning library. And if I scroll down, I'm gonna see the data set description. Some variables, they actually categorical, like sex. If you look it up here, the values are male and female, right? 0 stands for female, 1 stands for male. Factor variable is a categorical variable where you have the predefined set of values, right? Sometimes when the values in the spreadsheet are 1 and 0, the spreadsheet gets read as the variable gets read as numeric. We need to, depending on what analysis you're running, at times you may need to fix it, especially if you are running some methods such as association rules that you're gonna see in week 3 of the course, where all variables need to be categorical, right? This is how you would handle a variable such as sex, and the variable has two discrete values, male and female. So let's go back to R. This is what I'm gonna do. I'm gonna run the function factor to convert the variable to a factor. Equivalent sex, I'm assigning it, and I'm applying the function called factor, and this is an input parameter. Here we go. So now if I scroll down, do you see the changes? It says it's factor variables with two levels. A level is a value of a variable, right? And here, instead of showing the first few values, I see that the first value the first observation has a value 1, because 2 means the value is the second level. See here, instead of the actual value, it displays the level. So the level is the valid value of a variable sex. Right now it's 0 and 1, right? So here it means this observation, the first observation, has a value 1, and the second one is 1, and here is an observation with a 0, right? Again, this is the str. It's not the actual data itself. It's an output of the structure, right? So if I run the str command on equivalent, it's just gonna show me this. Oops, I mistyped it. Okay, so what let's do copy and paste. So what I do is here str, right? And in parentheses I put this. Here we go. See this? This is essentially the output of str command. It's a structure, right? But now what I want to do here is that I want to show you, I want to run this summary command, and after you run the factor command, notice that instead of displaying the minimum maximum value, I see that the variable has values 0 and 1, and here is the number of observations that have each value. So one way to verify that the factor command worked as expected is to run a summary command, and you're going to see the change, right? I no longer see my minimum and maximum, right? I see this. Also, another way to do that is factor command. It's going to show me if the variable is a factor variable, which is true. Now here, levels command, it's going to show me, in general, levels command shows it shows the values, the valid values of the factor variable. Like if I run it here now, if I run this levels command now, it's going to show me that the values are 0 and 1. I want to change it, right? I want to change it here. I want, instead of 0 and 1, I want it to be female and male. To do that, I have to run the levels command, right? Levels, and this is the variable name, right? Here is an assignment operator. C is a list, and I'm listing it female and male. It means that 0 is going to be female and 1 going to be male. Let me run this. Now, after I do that, I need to validate that the command worked as expected, and see this, it did. I no longer see 0, 1. I see male, female here, right? And what I can do also, I can run the summary, and it's going to show me each gender and number of people with each gender. I can also do levels, and it's going to show me male, female, right? Now what I'm going to do the same thing to my CP variable. And here are the values, and I pulled them from the dataset description. So I'm going to run the factor command, and here I'm going to record this. Well, basically, in this demo, I'm showing you how to do it. But in some exercises that you do, you want the variables to be numeric, and in some you want to be categorical. But what we're doing here now, we're working on data exploration and available filters, right? That's what we're doing right now. Here we go, right? Now I'm gonna show you the table command. Table command is gonna produce my frequency count. So basically it's gonna show something like this. In this case, it just coincidentally matches. It's gonna show me my values and the number of data rows or observations that have each value table. Oops. Here we go. This is a table. What I could also do is I could do the proportions table. Instead of displaying how many people, right, I have with each value, it's going to show me the proportion of people with each value. I'm going to run. Now what I can do is I can do by two variables. I have two categorical variables, and I want to build it. It's something similar like a crosstab. You can call it a crosstab table. And I'm going to do it like this. So notice which variable goes horizontally and which variable goes vertically, right? So here it is. It's showing me here is a CP and here is a gender. What I could do is I could turn it around just by sweeping these variables here, right? What I could also do is I can also display my proportions, wrap table, right? And this, it's taking a table as an input. I forgot to mention here that the proportion table is taking table output as an input, right? You can nest the commands. So what I'm doing in here, now, do I like how it looks like? Probably not. What I want to do is I want to round it, right? I want to round it like this to the decimal point, right? Or I can also display it as a percentages, and you can just multiply it by 100, right? So that's going to show me as percentages. What I'm going to show you next is packages. This is important because starting from assignment 2, from exercise 2, you're going to start using packages. Package is basically a piece of functionality, right? It's a set of functionality, set of functions. Some functions come in with a RStudio installation, and some of them are not. For instance, you're going to be using the discretization or the binning to convert the numeric variables into the discrete, right? And that function does not come with R installation. You would have to install a package. Now see, the system variables is everything that comes with R. Non-system user variables is everything that you need to install. So, to view the list of available packages, you need to run this browse URL. This command is going to open the browser, and it's going to show me the page of available packages, right? Somebody asked me that question before, so for this reason, I included this command to presentation this time. So here is a command to get the list of all available packages. Library command is going to show me which packages I have installed on my laptop, right? List the installed packages. So here it is. It's going to list everything that I have in here, right? It's going to list it here. Let me close this out and close. Okay, and the search command is going to show me the list of packages that I have in memory. So what it means, the package is installed, it means it's there, it's physically on my hard drive. In memory means it is available, right? The package is not available if it's not in the memory. This shows me what I currently have in memory, right? To install the package, you're going to run this command, install that package, and inside you're going to put the package name. And what we're going to do here, this command shows you, this command installs a rules package. I'm not going to run it right now because I already have it installed. But basically this is how you do it, right? Install packages or rules. You do it only once, right? As long as the package is not uninstalled, it should be there. But the package is currently unavailable. If I try to use it, if I try somewhere down the line, if I try to run this command, I'm going to get an error message because this function is defined inside this package, inside the package, right? The fact that I have the package installed does not mean that I have it ready to use. So there are two ways to do it. One way to use the library command, one way to use require command, and yet another way, I can go here and I can check mark. I can find my package. I can put a check mark in here. That's one way. And here I see the message in red. And what it does is it actually loading the package for me. It's not an error. Some messages that you get are just an information, right? It's not an error. But another thing I wanted to mention that I want my code to be reproducible, right? So that's the reason I put my command here. Now, here, this is how to open package documentation. You put a library command, put help, and here is a package name that you want to see the help on. There we go. So it opens the help page on my package, right? It's almost same information that you're gonna see in here in a help tab. Let me close this out. Here, VNet basically is an example. Some packages have examples on how to use, right? So this one, it's supposed to open the package VNet. Here it is, right? It's gonna open the package examples, and some packages have it, some packages don't. And what you can do is you can run browse VNet command, and it's gonna show you which. See this? It's gonna open up the window. It's gonna open up the list of VNets for the package. VNet is a synonym for examples, right? And here, this command, this is something that you want to do regularly to make sure that you have regular package versions. I'm not going to run it, but what it's going to do is it's going to check if your packages have the latest version, and it's going to update them. And as you run the command, you might be prompted if you want to install the package in your local library. And the reason is because you want to be able to install it directly in a folder where others installed, right? Because you cannot write explicitly in the program file. You have to write it in a local folder. This is a location. This is the location of the PC where the package will be installed. Right? R, Win library, and here 3.3. So now, here I'm not going to run it, but I have it in case you would need to use it. In order to unload the package from memory, one way to do it is to uncheck this check mark. Or here, this is how you would run the command, right? And here is how to remove the package permanently. Permanently means you uninstall it. It's not going to show in this user library anymore, unless you install it again. Now, what I'm going to do is I'm going to do discretization. Discretization is also called binning. That's another way to call it. Age variable is continuous, right? Age is a number like 70, 75, 60. What discretization does is it divides my variable into bins, and I'll show you what I mean. So here, I want to divide the age values into 5 intervals, right? And I have several options. I want to have my intervals, I can have my intervals of the same length. For instance, I want one bin to be values from 1 to 20, one bin to be values from 20 to 40. I'm just making up hypothetical numbers, right? So if I have values from 1 to 100, I want the first 20 to be the first bin, the next 20 to be the next bin. So I want it to be based on a values range, regardless of how many observations have a value in that range, right? So that's what interval means. Discretize is a function name, and the function is located in the rules package that I just loaded. Now, very important, there is a package called discretization. However, if you just load discretization to memory, that won't do it. You need to have a rules loaded into memory. It's a rules, right? So let me go ahead and run this. Discretize. Well, I just ran it. However, I really cannot see what I did because I just assigned it. What it did was it created another variable. Remember, we talked about creating another variable. And if I scroll down, see this? It showed me that it divided this into 5 value ranges, right? Yeah. So, but to really see this better, you want to do the summary command, right? So let me do this. I'm gonna copy Control C, and oops, let's do this, Control C, and I'm just gonna write summary, and then in here I'm just gonna put my variable name, right? See this? What it did was it created it split my values into ranges. The ranges are approximately equal widths, but see this, the first one has 11, the fourth one has 107, right? So that the number of instances that have a value in each range is not necessarily the same. Here, I want it to be based on the frequency, right? And I'm calling it H frequency, right? So I want to have approximately the same number, right? There we go. And this is another one, cluster. So basically what it does, it finds, we're going to discover clustering later on in the course. But it's going to try to find the cluster centers. It's going to randomly find 5 centers. It's going to assign the point to the closest center, basically. We're going to learn more, but what I want you to do here is that I want you to observe the differences, and then I'm going to show you. Here is fixed, right? So fixed means that I want to explicitly specify the boundary points. Inf means negative infinity, minus int, negative infinity, right? So it means that it's just a negative number. Here, my first range is going to be anything below 30. My next range is going to be 30 to 50, 50 to 60, 60 to 70, and everything above 70, right? Another thing I got to point out, notice that the square bracket, it means the value is included, and the circular bracket, it means the value is excluded. So 58.7 is going to fall in this range here, right? So I'm going to run the fix command, and I'm going to run the summary. I do that because I want to verify that what I did, in fact, worked, right? So also, if you notice it, frequency, right? It's approximately the same, right? Cluster is going to try to preserve the original variable distribution. It's going to try to preserve the distribution. I'm going to show you what I mean. And I'm going to cover the plot command. But the reason I have it here is because I wanted to see the difference. So here, what I want to do here is that I want to put 4 plots. I want to have the 4 plots on the same page, so to speak. So 2 by 2. That's what it does. Right? So now I'm gonna run this. I'm gonna plot this. It's a plot command. Here I'm specifying which variable I want to plot. It's a categorical variable, and main means title. So let me run this through. 1, 2, 3, 4. So now what I did was I have to turn it off because my next plot I don't want it to be 4 per page anymore. Now it's very difficult to read, so what I'll do is I zoom in. And I wanted to see the difference for the frequencies, right? So here is an interval. Notice that the frequency is uneven, right? The number of instances in each bin is uneven. It's an interval. What we were concerned about is that this values range, right? We did not care how many instances fall in each range. Here is a frequency. Notice that my distribution is lost, right? Here is a cluster, and here is fixed, right? So later on, what you could do is you can plot the histogram for this variable, for the original H variable, and compare which histogram looks like the original distribution, right? So, well, basically, there are many things we want to keep in mind when we select the number of bins and when we choose the discretization type. So I believe in your exercise you need to pick 3. So pick any 3 out of these 4 and There's more explanation in exercise walkthrough. Let me close this out. Now, very important topic is missing values. What is missing value? It's just not specified or unknown. As you may recall, earlier tonight when I ran the summary command, I showed you couple NAs, right? So if I run this summary equivalent here, it's gonna show me that my data set has missing values. Alright? See this NA, it means the value is missing or omitted. And why is it a problem? What is the problem? Take a look at it. I'm going to get the mean value of the variable CA, right? Which is, see this, there are 4 missing values, and I'm trying to get the mean. What's gonna happen? See, it returned an A. That could not calculate my mean. One way to just do it temporarily is to say an ARM equals true. An ARM means to ignore missing values. NA.rm. So it's secretly behind the scene, it's removing the missing values for the computation purposes. It does not handle the missing values in the data, but it just tells R to ignore them when computing the mean, right? So that worked. But what we want to do is, here are some commands, and I'm giving you a lot of options just to show you that there is more than one way to do the same thing in R. So basically, the command isNA returns, the command isNA by itself, it's going to return if the value is missing. isNA, it's going to return false if the value is not missing, true if the value is missing. So here, I'm running it for all data, right? I'm running it for all data. And whenever you see whenever you see value true, it means that specific observation, is missing a value for that variable. Now, this is very difficult to interpret. So what I want to do here is I want to check if any data set, if any variable in any row has missing value. So here you have to run an any command. Any, and you pass this as an input. That's one way. Any, right? True. If it returns true, so that means that I have at least one value. I have at least one missing value in my data set if it returns true, right? So that's one way to verify. So one way to check if your data has any missing values like this, true, right? You want to run this command. Now, how many values are missing? Instead of any, I'm going to do the sum. So sum is going to calculate how many I have true, right? Because remember, when I ran this command, it returns a bunch of true and false, right? So I'm going to do the sum of true. So that means I have 6 missing values total, right? I have 6 missing values. Which command is going to tell me which data rows are missing a value, right? It's going to show me the index. It showed me the index 155, 178, etc. So this is an index of the data row where the value is missing. Now here, this is one way to display the observation where at least one value is missing. So notice that incomplete. See, this is the negation sign. Complete cases by itself is going to return the rows that are complete, that do not have anything missing, right? So this returns all this. Basically, what it's going to do is, actually, look at this. It's going to show false, right? It's going to show false. It means that that specific data set row is incomplete, right? It's going to show me here, this command by itself, it's going to show me which data set row is missing a value, right? False. It means it's incomplete. See this? Here, it showed me 155. Data set row 155 has a missing value, right? 155. When I scroll down here, take a look at this. 155. It's false. And 155 is an index of this element. See this? And same thing here, right? So here I got more details. And here, what you want to do is, remember, this is a conditional selection. I want to choose incomplete, right? I want to choose the false ones. I want to choose where this is false, right? And I want to pick all variables, right? Here it is. So it's gonna show me the data rows that have at least one value missing, right? Remember this? We were doing the conditional subset before. This is where it becomes helpful. Now, here, this one is a little bit of bonus. You don't need to do it this way. I figured out a simpler way for you to do it, but basically, if you want to see how many instances are missing a value for each variable, one way to do it is just to take the column sum. Because isn't A, it's going to tell me if the variable is missing, right? Is an A, it's going to return true if the variable is missing. See this? It returned this here. Column sum, it's just going to add how many values are true, right? Column sum is just going to be the sum of true. So see here, the output of the command that I just ran before shows true if the value is missing. Column sum is just going to add the number of truths in each column. Here, this is one way to do it. Basically, apply means that I want to apply some function. I want to apply some function on every variable, right, in my data set. And the function is basically what we did here, column sum. This is a sum, right? It's something similar. For each column, I want to select the sum, this, right? This is one way to do it. This is another way to do it. But this shows you inline function. This is an inline because I won't be able to reuse this function anywhere else, right? This is only visible in this command. Now, there is more than one way to handle missing values. Earlier, I showed you the mean. When we computed the mean, there was an option to just ignore, right? And ARM equals true. The problem is not all functions that you're going to use have this option, right? Not all functions that you're going to use have an option to ignore missing values. So you need to handle them. And how you handle them? Well, you have to look at how many instances are missing a value, right? The commands that I ran before for you. In some cases, if you have a variable where half of the instances are missing a value, you may want to just remove the variable. Right? Sometimes, if your data set is large, you want to remove the data row that have a missing value, and omit. That's a command, an omit equivalent. So this is going to return only complete rows. And here I'm creating the new data frame, and here's my assignment, right? There we go, right? Another way to do it is to do the conditional. See here? This is something different. Oh, let me show you. This is something different. This is going to show me this is supposed to show me the incomplete. Okay, here it is. And I'm going to run this again. And then here's my new equivalent. See this? That's what I did. What I did here was I removed the rows with the missing values. That's what I basically did. And here, oh, it just showed me that, yes, I'm not sure. I have to delete this. This is wrong. There we go. This is the right command. Let me save this. Okay, so here what I did was I only wanted to select the complete cases, right? So this is a copy of this. And I removed the cases with missing values, right? And to actually verify that the missing values were removed, you can go up there and you can run this command in here. You can run this command, right? However, instead of equivalent, it's going to be the new equivalent. Right? I'm going to do this. Right? So in your homework assignment, this is how you do it. When you ask to verify that the missing values were removed, you just run this and it returns false, right? It means there are no more missing values. That's one way. However, it's not always an option. What if my data set is very small, right? And I have only a couple rows missing a value. You have an option to replace the missing values with the variable mean, right? So remember this. Here is how you take the mean, right? I want to say an ARM because I want the mean to ignore missing values, right? I want my mean to work. And here, what I'm doing it, remember, is an A. It's going to return me if the value is blank, right? So here I'm specifying that I want to take the blank values and replace them with the variable mean, right? So let me run this first. So what I did here, I created a copy of my data set. I want to play around with a copy. So what I did here was I replaced the missing values, right, with the mean. Alternatively, I can also replace the missing value with a predefined value. Like for instance, I want to set all missing values to 0. It's just an example, right? So this is one way. Here is an alternative way. Here is an alternative way to change to set the missing values to 0. This is the if-else function. So here what I'm saying, if this is blank, right, we set to 0. Otherwise, keep it as is, right? So here I'm just basically showing you more than one way to do the same command, right? And here I do the summary. Notice that NA disappeared, right? It does not show anymore that there are missing values. Now I'm gonna show you some data visualizations. So really quickly, the visualizations that you use depends on the variable type, right? If it's a categorical variable or if it's a numeric variable. So histogram we're gonna use for numeric, and it's gonna show the frequency. There we go. Age. See how the age variable looks like, right? And do you remember earlier we were looking at the age, right? We were looking at the age. So see this? Keep this in mind when you're doing the discretization. Now let me close this out. Now what I did was, see these errors? It allows navigating between plots that you ran in this session. Now what I want to do is I want to change the number of breaks. That's one option. Breaks. I'm just showing the options, right? It just changes the number of breaks, and you can play around with colors and so on. Now, there is another visualization called a bar plot. Bar plot takes the frequency table. Do you remember earlier we were doing the frequency table? The bar plot has to take the frequency table as an input. What we could do is, one way to do it is to create a variable, let's call it H table, and we store the frequency table in that variable. Here, I'm just gonna, when I put just the variable name, it's the same thing as a print command. If I just put the variable name on the line itself and run it, it's gonna do the output. Here we go. So that's a frequency table. It shows me how many times each value, right? How many instances have each value. So now what I can do is I can do the bar plot. See this? I have to put in this frequency table right here. Right? This is my bar plot. In order to see all labels, I can do zoom, right, and then I'll see it. That's one way. Now, what I can also do is I can order it, right? I want my bars to be ordered. That's one way, right? I can order it, or I can change the orientation, horizontal. Now, similarly, I can do a pie chart. Now, pie chart also takes the table as an input, frequency table. Instead of creating a separate variable, this time I just put a nested command. right? So this is my pie chart. And here is a box plot is for numeric variables, right? So box plot. And here is a generic plot function, but basically what it does, it was programmed to recognize the variable type. Depending on my data type of the variables that I put in, the visualization type will vary. So let's try this equivalent CP, right? It's a categorical, and here are my values. See this? And it's going to show me the frequencies, right? So now what I'm going to do is, here I can do another variable, but notice that here it's a frequency. I want to plot the frequency count, right? Here it is. That's a frequency count, but I said the type equals L. So it means instead of bar chart, I want to see a line. That's possible. Here I have two categorical variables, so it's going to look like the mosaic plot. And here I have a single numeric variable, so just going to put the dot points. Here is the y-axis is the value of the variable, and the x-axis is an index, because I did not specify, right? Here what I can do is I can specify what I want it to be, right? Both x's, right? I can specify. So what you can do is you can play around with colors, but here this is my first bonus. What we're gonna do, there is a colors command, and it's gonna show you the list of available colors, right? So now, when I do the bar plot, the first input parameter is what I want to plot, right? Table, H interval, right? Here, I use a color argument, and the violet is going to be the color name that I want to use. I can use the color name, or I can use the index. See, violet is 360 because here it shows me the index of the first element in this row, right? So this is two ways to do it, to get the same result, right? Here, I want the bars to have a different colors. I have 5 bars, and here rainbow. It's just gonna generate 5 colors here. There we go. So I'm just showing it's a little bonus. And here is another bonus, last bonus, and this one is for paying the undivided attention over the last hour and a half. What you need to do I want to plot the 3-dimensional. I want to do a 3-dimensional plot. To do this, you're gonna need to install package plot3D, right? You load it into memory. Here, what I'm doing is there is a function called scatter3D, and I'm defining my x-axis, my y-axis, my z-axis, and here is a variable I want to use for the color, right? I could do that. So basically, I could also put these guys in here. I created a separate variable, but I could but I want this to be more readable, right? So what I'm gonna do now, I'm gonna run this first. And now I'm gonna do this, I'm gonna run this one first. See this? This is the default. And it's unclear at the moment what the color code will represent, but we can fix it. And what we'll do right now is we're gonna say that the color variable is this, presence. I want you to use a different color code to indicate if the person has a risk for the heart attack. And here, I want to rename my x-axis, I want to rename my y-axis, and I want to rename my z-axis. And here, this specifies the rotation. Basically, it's a viewing angle, and it has to do with the polar coordinates. Yeah, let's just run this. See this? And I can do the zoom in. And at your leisure, you can play more with this. So here, see this is main. Main, it's going to be the title here. And I change the variable names. Alright, so you're going to guys have a copy of this script. So I've been talking for about 1 hour and 25 minutes. Now, guys, it's your turn to ask me questions. And if you may have worked with me before, I love questions. So go ahead and type your questions in the chat, please. And I'm going to open the chat window. Oh, okay. So I see it. Susan, I hope everything is all right. I hope you were able to dial in, right? I hope so, because I see your message in the chat that you had some difficulty. Okay, so yes, definitely. The code will be posted for you guys. This code will be posted, and also the data set that I used and the slides as well, because if you look at it here, what I did was I put together some tips for you. I put together some important tips. So something to keep in mind, that RSK sensitive, you want to save all commands in a script, right? And yes, Eric, thank you very much for assisting student with the audio. I appreciate it. Anyway, so here are important tips, right? You want to save everything in the R script. You want to add the comments. Use the help function, right? There is more than one way to reproduce the same result. Packages enhance the functionality. And here is update packages command that you want to run regularly to make sure you have latest and greatest versions. And here you need to keep in mind that the package is unavailable until you load it into memory. So you need to run either library or require command. And when you run in the walkthrough code, your code might be slightly different depending on the R version that you're currently using. And the R is getting updated all the time, as you may have noticed. So there is a possibility that the assignment, the walkthrough, was written with one version lower, right? Or there could be the package could have been updated. Well, usually it's still gonna work, but the numbers in your output, it's highly possibility to get slight difference. So it's possible, just keep that in mind. And I would strongly recommend to start working on assignments early. That way you allow yourself some time to debug, right? And it might be helpful sometimes when you get an error message. If you copy this message in Google, you'll be amazed what you may find. You may find the solution, because some people have solved it already, right? So go ahead and please type your questions. Guys, I like questions. Or if you don't have questions, I'm gonna start asking questions. Is lowercase and uppercase R is the same? Think about it. Oh, you're the most welcome, Mohammed. Yes, the recording would be available, sure. And yes, go ahead and put your questions in the chat. Or you also have an option to. Oh, all right. So I see what you mean, Mohammed. So for the next WebEx, I have a recommendation. What you could do is, while the TA is running the presentation, you could type your questions in the text editor or in the chat. And later on, when the floor is open for questions, it will be picked up, right? Oh yes, I agree with you that we did cover a lot, and that was my goal, to make sure that the session is productive, and it's a customer service, I call it, right? We want to have time productive, and then you're gonna have a recording, you'll be able to go back to it, and you'll have a copy of the script, so that way you can follow along as you listen to recording, right? So it's a perfect opportunity for you to ask questions. Will we have a lecture session every week? Well, maybe every other week, and we're gonna take turns. Eric is gonna do, and John is gonna do. We're gonna be doing it maybe one per module. We'll try to do it one per module. So I really want to make sure that it's helpful and so on. We're gonna help. We're gonna help you. We're here to help you. So it's a customer service, right? So guys, please go ahead and ask questions, and even if you have questions afterwards, you can pose them in a discussion, and they will be answered. So I'm gonna go ahead and stop sharing my screen for right now. Oops, stop sharing. So let's see, what questions do we have? Going once? Going twice? If you don't have a question, then I want to thank everybody for being here, and I hope everybody has a good night and a nice first week of class, right? Okay, thank you. I'm gonna stop the recording now.